Revision of visualizing solid shapes. Views of 3D shapes. 3D means 3 dimensions, length, breadth and height, or simply the depth. 3D objects occupy some space or volume. This is the diagram of a 3D object. Whenever you view a 3D object from front, it is called as the front view. Whenever it is seen from side, it is called as the side view. Whenever it is seen from the top, that is called as the top view. Whenever you see it from front, side or top, you have to assume that you are seeing it from very far. So when you see it from the front side, you see these 3 squares and this square. So this is the front view. Whenever you are seeing it from side, this square and this square will be seen. The depth will not be seen. These 3 squares will appear in the same line. So that is the side view. Top view, when you see it from top, this height will not be seen. So these 2 squares will be seen in one line. So this is the top view. Faces, edges and vertices. Each of these solid shapes, they are made up of polygonal region. These polygonal regions, they are called as faces. Faces, they meet at edges or the line segments. Line segments or the edges, they meet at vertices. Those are called as the points. Each of these solid shapes, they are called as polyhedrons. And these are not the polyhedrons. Their faces are curved. Convex polyhedron. Convex polyhedron, the concept is similar to your convex polygon. In a convex polygon, the diagonal lies fully inside the polygon. Similarly here, whenever you join any diagonal, that will lie fully inside this 3D object. So these are the examples of convex polyhedron: cube and hexagonal prism. Here, not a convex polyhedron. You can see these, if you join these 2 points, it is a diagonal. What is the definition of a diagonal? Whenever you join 2 non-consecutive points, then the diagonal is formed. For this vertex, you see this is a consecutive point. This is non-consecutive point. So if you join this point and this point, a diagonal is formed. And here the diagonal is lying fully outside this polyhedron. So this is the example of not a convex polyhedron. Regular polyhedron. Regular polyhedron, each face is a regular polygon and the number of faces then the number of faces meeting at a vertex should be same. Here this is a cube. 3 faces, they are meeting up to form a vertex and each face in a cube is a square. Let us take this 3D object. You see, each of these faces of a 3D object is an equilateral triangle. But there are 3 faces, they are meeting up at vertex A. And here at vertex B, there are 4 faces, they are meeting up at vertex B. So, that even though each face is a regular polygon, here it is an equilateral triangle. But the number of faces which are meeting at vertex A is 3 and the number of faces meeting at vertex B is 4. So this is not a regular polyhedron. Let us now discuss prism and pyramid. Prism is a polyhedron in which the top and the bottom faces are congruent polygons and the lateral faces are parallelograms. In pyramid, pyramid is also a polyhedron in which the base is a polygon of any side. The lateral faces are triangles which are connected to a common vertex. Both prism and pyramid, they are named after its base. Here the base is a square, so we say this is square prism. Here the base is a triangle, so we say it as a triangular prism. Let us write it down. So here the base is a square, so we will say it as a square prism. And here the base is a triangle, so we say it as a triangular prism. Here the base is a rectangle, so we say it as a rectangular pyramid. Here the base is a triangle, so we will say it as a triangular pyramid. The other name for triangular pyramid is tetrahedron. Similarly, for square prism, it can be cube. or cuboid also. Can a polyhedron have 10 faces, 20 edges and 15 vertices? For any polyhedron, Euler's formula holds true. Let us write it down. F plus V minus E equals to 2. F is number of faces, V is number of vertices, E is number of edges. Let us solve this. On left hand side, we have F plus V minus E. So number of faces is 10, vertices is 15 and edges is 20. So 25 minus 20 is 5. On right hand side you have got 2. So left hand side is not equals to right hand side. This means that Euler's formula does not hold true. So this figure, this solid shape is not a polyhedron. So the question asked here is, can a polyhedron have 10 faces, 20 edges and 15 vertices? The answer is no.